In this question, you are asked which statement describes an electric source of 5 volt. Now, straight away, you should know that electric source is like the battery. So that will be your EMF and EMF of 5 volt. So usually you are so used to those straightforward questions. What is EMF or what do you mean by EMF of 5 volt? But for this question, the options are a bit different. So let's look at the basic first. So what is EMF? And the definition you must know is the work done or energy needed to carry a unit charge. And the unit charge literally means one coulomb of charge around the whole complete circuit. So if you understand the meaning, and if they were to ask you what do you mean by EMF of 5 volt, so that means to say you need 5 joules of energy to drive a unit charge around the whole complete circuit. I can also use the formula. Okay, you should be very familiar with E equals to VQ. All right, so if your EMF right now is 5, and to bring a unit charge that's one coulomb, you will need 5 joules of energy. So this is what you have been familiar with, and the options usually are quite straightforward. But for this case, I mentioned that it's a bit different. Let's look at all of them now. Let's start with C. Alright, C, many of you will just straight away, because of the definition you understand, you will say that 5 joules of energy is needed to push around the whole complete circuit. And if you are not careful, you might choose C. But take note of this. This is an electron. One electron is not the same as one coulomb of charge. Now, even though you're not required to memorize the charge on the electrons, it's about 1.6 times 10 to the power of 19 coulomb. That means to say, in one coulomb, you take 1 divided by 1.6 times 10 to the power minus 19. That will be 6.25 times 10 to the power 18 number of electrons. So take note of that. So C will be wrong. Another one that you can just cancel off is A, because you understand that it's the work done, not the power. Alright, to push the charge around the circuit, that's not power, energy is joules. So A will be wrong also. Let's look at B now. 25 joules of energy is needed to push or drive or carry 25 coulomb of charge around the circuit. Now, from first glance, some students may think that this is not related to your definition, which is with respect to one coulomb of charge. But this statement is correct. The question never asked for definition, but rather, if you think of it, this is your energy and this is your Q. E equals to VQ or V equals to E over Q. If the energy to drive the 25 coulomb of charge is 125 joules and the amount of charge is 25, if you work it out, that will be 5 volt, which is the EMF. Alright, so that is correct. So B will be the answer. Now, of course, if you want to do the same method here for option D, alright, even though they mentioned 3 electrons, of course, if you want to play safe, you can just take this times 3, that's the amount of charge, and you take 15 divided by the amount of charge for the 3 electrons. Of course, the answer you will not get 5, so D is also wrong. Alright, I hope you understand the question now. Thank you.